Crack the code of math. Let's learn about factorials. What is a zero factorials? How to calculate factorials? Is there any means that factorials can be applied in real life? If you want to know, let's begin.
The modern notation for factorials and the formalization of the concept are often attributed to the Swiss mathematician Leonhard Euler, who introduced the exclamation mark notation, which is known to us as factorials. However, it is important to note that the idea was not discovered by only a single individual, but rather developed over centuries by various mathematicians from different civilizations. The earliest known mention of permutation and combination, which are closely related to factorial, can be traced back to ancient Indian mathematicians like Pingala around 5th to 2nd centuries BCE. What is therefore a factorial? A factorial is a product of all positive integers from 1 up to a given positive integer n. It is denoted by n factorial and is calculated by multiplying all the integers from 1 to n. Mathematically speaking, the factorial of n is expressed as n times n minus 1 times n minus 2 times ... times 3 times 2 times 1. For example, 5 factorial is equals to 5 times 4 times 3 times 2 times 1, which is equal to 120. Another example, 3 factorial is equals to 3 times 2 times 1, which is equal to 6. 0 factorial is defined to be 1 by convention.
While this might seem arguable at first, let's provide a simple explanation for why 0 factorial is equal to 1.
So, the reasoning behind this definition is based on the fundamental idea that when you have no object to arrange, there is one arrangement possible, the null or an empty arrangement. How about double factorial? A double factorial is a type of factorial where every second term in the product is used. There are two main types of double factorials. The first one is the even double factorial. The even double factorial of a positive integer n is the product of all positive even integers less than or equal to n. It is denoted by n double factorial and is calculated by multiplying all even integers from n down to 2. For example, 6 double factorial is equals to 6 times 4 times 2, which is equals to 48. 8 double factorial is equals to 8 times 6 times 4 times 2, which is equals to 384. The second one is the add double factorial. The add double factorial of a positive integer n is the product of all positive integers less than or equal to n. It is also denoted by n double factorial and is calculated by multiplying all the add integers from n down to 1. For example, 5 double factorial is equals to 5 times 3 times 1, which is equals to 15. 7 double factorial is equals to 7 times 5 times 3 times 1, which is equals to 105. Double factorial has some application in combinatorial mathematics, particularly in the problem of arranging an object in a pattern that skips every second position, or in a situation where a pair need to be chosen or arranged in a specific order.
Is there a triple factorial?
Yes, there is a concept known to us as a triple factorial, which is an extension of a factorial and a double factorial. However, the use of triple factorial is not as common as the single factorial or a double factorial.
Down to our last question. Is there any means that factorials can be applied in real life?
Factorials have various applications in mathematics and beyond. Thus, the answer is a very big yes. Here are some common uses of factorials. Arrangement and permutations.
Factorials are used to calculate the number of possible arrangements of items. For instance, in a cooking competition, if you have 10 contestants and you want to know how many ways they can finish in first, second, third, and fourth place, you'd use factorials.
Combinations.
Factorials are used to calculate the number of ways you can choose a subset of items from a larger set without considering the order. This is helpful in scenarios like picking a committee from a group of people.
Probability.
In games of chance, factorials are used to calculate probabilities. For example, in a lottery, you might want to calculate the odds of a specific combination of numbers being drawn.
Seating arrangements.
When arranging people in seats, factorials help calculate the number of different possible seating arrangements. This is relevant in event planning and venue organization.
Coding and algorithms.
Factorials are often used in computer science and programming to test algorithms and functions, especially when dealing with permutations and combinations.
Statistical analysis.
In statistical analysis, factorials are used in experimental designs and in calculating various permutations of data points.
Genetics and biology.
In genetics, factorials are used to calculate the number of possible combinations of alleles in offspring.
Q theory.
Factorials have applications in Q theory, which deals with the analysis of weighting lines and Qs. This is important in fields like operations research and customer service management. These examples demonstrate how factorials are used to solve practical problems and make informed decisions in various fields, from entertainment and gaming to science, technology, and industry. Let's try some of the common questions that are always in the entrance or qualifying exam that include factorials. Feel free to pause if you want to try. You can check the description below for the solution.